Welcome back, everyone. If you're dialed in and ready to level up, you are in the exact right place. We're diving deep into the trenches of system design today. This is day 3 of our journey, and we're tackling one of the most absolutely crucial make-or-break skills an architect can possess: capacity estimation. Consider this explainer your tactical mission briefing. We're going to look at exactly how to predict the resources your system will need before it actually goes live. Because let's be real, in the world of system design, guessing is just not an option. It is literally the fastest way to rack up a massive cloud bill, or worse, completely crash on launch day.
So let me ask you a very direct question right off the bat. Are you ready for 1 million users? I mean, it sounds like an absolute dream scenario, right? Your application goes viral, the user count just skyrockets overnight. But without the right architecture in place, that dream instantly turns into a vivid nightmare. Just imagine your startup hitting the front page of Reddit or getting this massive shout-out from a major influencer, and instead of capturing all that incredible momentum, your servers just instantly melt down. You're looking at data bottlenecks, dropped connections, and endless error screens. Well, the architectural concepts we're unpacking today are the exact tools you need to survive and, honestly, truly thrive at this kind of massive scale.
Okay, let's dive into this. Here is our exact syllabus for today's mission. We're going to learn about users, requests per second, storage, bandwidth, the read-write ratio, and peak traffic. We aren't treating these as just vocabulary words to memorize. Think of these 6 specific metrics as your definitive blueprint. They're the interconnected gears of a massive machine, and understanding them is how we're going to conquer our final challenge today.
First up, Phase 1, understanding scale and traffic. We're shifting our focus directly to how we actually measure the foundational footprint and velocity of our application. And it all starts right here with users. This is the baseline metric of scale. Every single architectural decision you make stems directly from this one fundamental metric, because knowing exactly who is hitting your system is step 1. But, you've got to dig a little deeper than just a flat head count. For instance, understanding your DAU, daily active users, versus your MAU, monthly active users, completely changes your baseline. A system with 1 million monthly users who just log in once a month? That requires a vastly different architecture than a system where 1 million users log in every single day to actively collaborate. You simply can't begin to estimate capacity if you don't know the size and the habits of your crowd.
But just having that raw user count isn't quite enough. We have to look really closely at requests per second. This metric measures the average velocity of your traffic. It essentially tells us how intensely those users are demanding resources over time. Think about it. 10,000 users casually checking a static application once a day is very, very different from 10,000 users aggressively refreshing a live financial dashboard every 2 seconds, right? Requests per second gives us a clear mathematical picture of the baseline load our infrastructure needs to comfortably process.
Moving smoothly right along to Phase 2, storage, bandwidth, and behavior. We are now connecting that raw traffic data directly to hard physical hardware limits and user habits.
First up in this physical block is storage. This represents our absolute data capacity needs. Whenever users interact with our system, they inevitably generate data. I mean, do the math. If 1 million users upload just one tiny 2 megabyte profile picture, wow, you instantly need 2 terabytes of storage. And that is just day 1. It's a cumulative metric. It grows exponentially. As a system architect, you have to understand that this dictates exactly how much cloud-based hard drive space your infrastructure must hold over time. And remember, you aren't just storing the raw files. You have to account for database indexes, metadata, and replicating that data across multiple geographic regions so you don't lose it.
But here's the critical follow-up question. What good is all that securely stored data if nobody can actually access it quickly? How exactly are we moving all that massive data around the network? Well, that is where bandwidth comes in. Bandwidth is the rate of data transfer. If your storage metric is the size of your massive data warehouse, your bandwidth is the multi-lane highway leading to and from it. If that highway is too narrow, you get a massive traffic jam, and you're going to have angry users furiously tapping their screens. We measure this in gigabits per second, and honestly, it's often the hidden bottleneck that takes down otherwise perfectly healthy systems. You could literally have the most powerful servers in the world, but if your network pipe isn't wide enough, your application will feel agonizingly slow. So, the crucial point is this. Your system doesn't just need to survive a normal, quiet Tuesday morning. It needs to survive the digital equivalent of Taylor Swift tickets going on sale. And that brings us to peak traffic, the absolute maximum velocity of traffic your system will experience. Remember earlier when we talked about average requests per second? Well, averages can be incredibly deceiving.
Peak traffic is all about those sudden, violent spikes. If you only design for the average daily throughput, your system will instantly collapse under peak stress. A well-designed system anticipates these surges with auto-scaling groups and aggressive caching layers to just absorb that shock without breaking a sweat.
And this brilliantly illustrates our next core concept, comparing system reads versus system writes, also known as the read/write ratio. This metric is absolutely fascinating because it's purely about how user behavior physically shapes your architecture. Here, we're strictly comparing how often a system fetches data, which is a read, versus how often it saves new data, which is a write. Take a platform like X or Twitter. It's heavily read-heavy. You have millions of people endlessly scrolling, but a relatively small fraction actually posting new content. On the flip side, a system like WhatsApp or a high-frequency stock trading platform is write-heavy, constantly logging incoming data points every single millisecond. Understanding this ratio dictates whether you need massive read replicas to handle the scrolling or heavily sharded databases for concurrent write operations.
All right, we've laid down the theory, we know our core metrics, now we are pivoting straight away from the sandbox. Welcome to the 1 million user challenge.
I just want you to let that massive number linger for a second. 1 million. Let the weight of that sink in. In system design, this isn't just some fun milestone to celebrate with a cake. It's a critical, highly demanding scale threshold that will easily break a poorly designed system. As the architect, this scale is now your direct responsibility. The database load, the thousands of server requests per second, the sheer volume of data being written and read simultaneously. Everything we just learned is now operating at a massive, unforgiving scale.
Let's move to and see how this builds into our exact roadmap for today's practice session. Step 1. Learn the metrics. We just crushed that. We successfully defined users, throughput, storage, bandwidth, peak thresholds, and behavioral ratios. Now, Step 2. Estimate the infrastructure. This is where you pull out the calculator and start doing the hard math. You take those 6 theoretical metrics and translate them into a tangible estimation of the real-world servers, database shards, and cache memory required to keep this whole thing running efficiently and cost-effectively.
Which brings us to our final provocative question, the ultimate boss battle for day 3. How will you estimate infrastructure for 1 million users? You have the definitive blueprint in your hands right now. You know the exact 6 metrics you need to evaluate to avoid a catastrophic crash. So can you translate those metrics into a bulletproof architecture? The theoretical briefing is officially done. The real-world practice starts right now. Grab a whiteboard, crunch those numbers, and I'll see you in the next explainer.